Everybody's building AI agents right now. LangChain, CrewAI, AutoGen, a new one every week. Here's what nobody tells you. The actual agent underneath is about 30 lines of code. No framework, no magic. By the end of this video, you'll have built one yourself, and you'll never be confused about what agent really means again. Let's go. Strip away the buzzwords, and that's the whole concept. A language model, some tools it can call. A loop that keeps going until the job's done. That's it. The frameworks wrap this in classes and config and clever abstractions, but they're all hiding the same simple core. Once you see it, you can't unsee it. So let's build that core, one piece at a time. Picture a circle. You send the model a question. It thinks, and instead of answering, it says, call this tool with these arguments. Your code runs the tool. You feed the result back. The model reads that result and decides what's next. Maybe another tool, maybe the final answer. Round and round until it's finished. Hold that picture in your head. Everything else is just detail. You need exactly 3 things. 1. A model that knows how to ask for tools. Claude does this out of the box. 2. The tools themselves, which are nothing more than ordinary functions you already know how to write. 3. A loop to tie it together. We'll build all 3 in Python, and I'll show you every single line. No hidden steps, and then the framework does the rest. Start with the tool. Here's a function that returns the weather for a city. Right now, it just hands back a hard-coded string, but imagine it's calling a real weather service. And that's genuinely all a tool is. A function that does something useful and returns a result. Nothing special about it. The model never sees this code. It only needs to know the function exists and what to pass in. Now you describe that function to the model. A name, a plain English description, and the shape of the input. Here, a single city string. This little block is the entire interface between Claude and your code. And the description matters more than you'd guess. It's how the model decides when to reach for this tool. Write it like you're explaining the tool to a new teammate. A vague description gets you bad decisions. Here's the first call. You hand Claude your message, plus the list of tools it's allowed to use. Then watch what comes back. The model doesn't answer the weather question. It can't. It has no live data. Instead, the stop reason comes back as tool use. That's Claude raising its hand and saying, I want to call your weather function with city set to Tokyo. Then it pauses and waits for you. This is the part people miss. Claude never runs your function. It can't touch your machine. All it does is return a structured request, the tool name, and the arguments as clean JSON. Running it is your job, and that separation is the whole security model. The model proposes, your code decides. You can log the call. You can require a human to approve it. You can flat out refuse. You're always in control of what actually executes. So you pull the tool use block out of the response, grab the arguments Claude filled in, and call your function for real. Then you wrap whatever it returned in a tool result block. The one piece that trips everybody up, that tool use ID. You have to send it back, so Claude knows which call this answer belongs to. Match the ID, attach the result. Now you're ready to keep the conversation going. Now you append 2 things to the conversation. What Claude said and the tool result you just built. Then you call the model again with the full history. This time it actually has the weather data, so it stops asking for tools. The stop reason comes back as end turn. Claude is done, and the final message is a normal human answer. It's 72 and sunny in Tokyo. You went from question to answer through one tool call. We just did 1 turn by hand. A real agent might need 5 or 15. So you wrap the whole thing in a while loop. Each pass, call the model. If the stop reason is tool use, run whatever tools it asked for, append the results, and go around again. The moment the stop reason is end turn, you break out and return the answer. That loop is the agent. Seriously, I think that's the entire engine. Here's everything on one screen. The whole agent. It takes a message, your tool definitions, and a lookup from tool name to the real function. Then it loops. Call the model, and if there's no tool request, return the text. We're done. Otherwise, it runs every tool Claude asks for because the model can request several at once, collects the results, and continues. Count the lines. That's a working AI agent, and there is not a framework anywhere in sight. Let's run it. You ask for the weather in 2 cities at once. Behind the scenes, Claude requests both weather calls in a single step. Your loop runs them, hands both results back, and the model writes one clean answer covering both cities. You didn't write any orchestration for that. You never told it to batch the calls. The model planned it, your loop carried it out. That's the moment this stops feeling like code and starts feeling like an agent. Real tools fail. The API times out, a file's missing, someone fat fingers the input. Here's the beautiful part. You don't crash. You catch the error, drop the message into the tool result, and flag it as an error. Claude reads that just like any other result and adapts. It retries or tries a different tool or tells the user plainly what went wrong. You're not building some giant error-handling state machine. You hand the model the bad news and let it cope. That's the agent doing real work, and here's the payoff. Want the agent to search the web? Write a search function, describe it, add it to the list. Want it to send email, read a file, query your database? It's the same move every time. The loop never changes. You're not learning a new framework for each new capability. You're just writing functions. An agent's power comes from the tools you give it, not from the cleverness of the loop. The loop is boring on purpose. Now, I'm not telling you frameworks are useless. They're not. A good one gives you memory across runs, automatic retries when a tool fails, streaming, logging, tracing, and a pile of pre-built integrations you'd otherwise write by hand. That's real value at scale. But here's my honest take. Reach for one after you understand the loop, not instead of it. Because when the abstraction breaks at 2 a.m., you'll be very glad you know what's underneath. One thing to watch because it will bite you. Every time around the loop, you resend the entire conversation. Every tool call, every result. So a 10-step agent isn't 10 cheap little calls. The context snowballs, and so does the bill. Opus 4.8 runs $5 per million input tokens, so a chatty agent adds up faster than you'd think. The fix is the same flavor as the build. Simple. Trim old results you don't need, or swap a cheaper model in for the grunt work. Just know your token cost. Let's lock it in. Write a function, describe it so the model knows when to use it. Call the model with your tools attached. When it asks for a tool, run it and pass the result back. Loop until the model says it's finished. 5 steps. That is every AI agent you've ever heard of, underneath the branding. The big ones add scale and polish on top. But this, right here, is the beating heart. So before you pip install the framework of the week, build this once. 40 lines, an afternoon. You'll read every agent announcement differently afterward, because you'll see straight through to the loop underneath. The magic was never magic. It was a model, some tools, and a while loop. You've got this. If this made agents finally click for you, subscribe. That's exactly what this channel does. Takes the genuinely cool stuff in AI and makes it make sense. Next up, we'll give this little agent a memory so it remembers things across runs. See you there.